Assalamualaikum, my name is Nurul Munira binti Abdullah. So today, me and my group members are going to present about logical implication. So let me introduce our group members, which is Nurul Munira binti Abdullah, Nur Shazwina binti Muhammad Ramzi, Nur Hadira Nugla binti Nur Sam, and lastly, Nur Farhana Bila binti Shaharuddin. For introduction, statement is a declarative sentence that are either true or false, but not both. It also called as a propositions. There are two types of statement, which is simple statements and compound statement. Simple statement is contains only one idea and can be assigned a true value. For example, Farha likes salted egg croissant, so it only have one idea on that statement. For the compound statements, is combine two or more simple statements and can be assigned a true value. For example, if it is a warm sunny day, then the family will go to the beach. So it have two ideas on that statement. Implication if then. The implication P implies Q is the proposition. If P, then Q. It is also can call as a conditional. P is called the hypothesis. P also can call as the antecedent or premises. Q is called the conclusion. It also can call as a consequence. For example, for P statement, it is a warm sunny day. For Q statement, the family will go to the beach. So P implies Q will be if it is a warm sunny day, then the family will go to the beach. For truth tables, an if-then statement is only false when the first statement is true and the second statement is false. For based on the truth on that truth tables, P is true, Q is false. So P implies Q will be false, and the others condition will be true. So what is the logical implication? Logical implication is if P and Q are arbitrary statements such that P implies Q is tautology, then P logically implies Q, writing as P implies Q. The meaning of tautology is a proposition that is always true. There are two methods that allow to test for logical implication, which is truth tables and law of logic.
There are two objectives that need to be accomplished. The first one is to prove that one statement is logically implies another statement using laws of logic. And the second one is to prove that one statement logically implies to another statement using definition of logical implication, which is truth table.
Okay, let's do some example. For example 1, construct a truth table to determine whether P implies Q and Q implies R is logically implies to P implies R. So, for the step 1, we need to transform logically implies to symbol. For step 2, we need to divide for A segment and B segment, which is A segment, we have P implies Q and Q implies R. For B segment, we have P implies R. So, basically, we just simply A implies B. So, how to determine how many rows and how many columns? So, we just simply 2 to the power of n, which is n, the number of variable. So here we have 3 variable, so we got 2 to the power of 3. So we got 8 rows. So how to determine how many columns? Here we have 5 operation, which is 4 implies and 1 conjunction. So we add all the column, also variable, total is 8. So we have 8 column. So here for P column, first row and until 4th row, we got true value. 5 row and until 8 row, we got false value. So for Q, 1 and 2 is true, 3 and 4 is false, and same goes to the below row. So for R, we just simply true false, true false, true false, and true false. So first operation, we do P implies Q. So basically implies just when first statement are true, and the second statement are false, the truth value got false. So here we got third and fourth row are false and other row are true. So for the second operation, we have Q implies R. So same goes to before this. When first statement are true and second statement are false, the true value are false. So here we got second and sixth row are false. So other statement are true. So for third operation, we need to do is 1 and 2, which is conjunction operation. Conjunction operation is true when both statements are true. Here we got true value at number row is 1, 5, 7 and 8. So the other value are false. Settle for segment A. So next we do P implies R. P implies R. We got second and fourth row are false. Other value are true. So settle for B segment. So we have A and B segment. So back to the basic is A implies B. So last operation is A implies B. So here we got for the last column, we got all true. So for the conclusion, since the last column is all true, which is it's called tautology. So the statement which is our statement is P implies Q and Q implies R is logically implies to P implies R.
For example 2, using the law of logic, show that R or R and P implies R or S. First step, we use assumption law for statement R or R and P implies R or S. As a result, we will get R implies R or S. Thus, since there is implication symbol, we have to change it using definition of implication, and we will get negation R or S. Next, we use associative law to regroup the statement. As a result, we will have negation R or S. Then, we use inverse law for negation R or S to get tautology or S. Last step, we get tautology by using domination of law. For the conclusion, since R or R and P implies R or S is tautology, R or R and P is logically implies R or S. Next, example 3. The question is construct a truth table to determine whether not in bracket P implies Q logically implies P and Q. From the question, to be more clear, we can write it like in step 1. So we will get not in bracket P implies Q implies P and Q. Since there are two variables which are P and Q, so the number of row will be 2 to the power of 2 equals to 4. And for the number of column, as you can see, there are 3 symbols which are negation, implication and conjunction. So we will get 4 plus 3 equals to 7. So the number of column will be 7. Now, let's construct a truth table. First, we need to write the truth value for P and Q. So for P, row 1 and row 2 will be true, and row 3 and row 4 will be false. For Q, row 1 is true and row 2 is false. So for row 3 and row 4, just repeat it again like row 1 and row 2. After that, we need to find the truth value for not in bracket P implies Q. First, we need to find the truth value for P implies Q. So the implication statement will become false if first statement is true and the second statement is false. So as you can see, only second row fulfill the condition, so the truth value for second row is false and the other row will become true. Not in bracket P implies Q has opposite truth value from P implies Q. So from row 2, the truth value is true and row 1, row 3 and row 4 are false. Next, let's find the truth value for P and Q. So, the truth value for conjunction statement will become true if both statements are true. So as we can see here, only row 1 fulfill the condition. So the first row will become true and others will become false. Last, we need to find the truth value for not in bracket P implies Q implies P and Q. Now, let's see at the column not in bracket P implies Q and column P and Q. As I said before, implication statement will become false if the first statement is true and the second statement is false. So as we can see here, only row 2 will become false and other row will become true. From the truth table, we can conclude that since the last column is not tautology, the statement not in bracket P implies Q is not logically implies P and Q.
In conclusion, logical implication make the statement become tautology or not. By law of logic and truth table, we can determine either a statement imply with another statement. So that is all from us. Thank you for watching. Bye!